Here we have an example where we have a function, a square root function, square root of negative 2x plus 7, and they want us to find f of x plus h, f of x plus h minus f of x all over h, then to rationalize the numerator, and then finally take the limit as h goes to 0. All this to find the derivative, or the slope of the tangent line. Okay, it's going to be a really long one. You probably saw that with the number of minutes on the video, which I do not yet know as I'm making it. So first off, f of x plus h. So maybe I'll just do that right here. F of x plus h. That means whatever x is, that's where you plug into the function, right? I think you know that. Or you wouldn't be at this point taking calculus probably. 2x plus h plus 7. I just plugged in minus 2. Just kidding. Minus 2. Just plugged in the x plus h, right? That's what it means. When you put x plus h in the parentheses, you just plug that in to the x slot and then distribute. And so we get, well, we get that, right? That good enough? Just distribute that minus 2, and there we go. So now that's the first one. We're off and running. Now they're going to get a lot uglier. Now to get the second one. Grab it, bring it on down. So we want to get f of x plus h minus f of x all over h. Okay, so what's that going to look like? So first off, f of x plus h. Well, we just found f of x plus h right there. So it is the square root of minus 2x minus 2h plus 7 minus, so this is f of x plus h right here, minus f of x. What's f of x? Well, f of x is right here. So that's the square root of minus 2x plus 7 all over h. So that's f of x. And so there we go. And that's it right there. I guess that's not too bad either. So we're done with 2 out of 4. Now, number 3 is going to be the really bad one. So what they want us to do is they want us to take this and rationalize the numerator in the difference quotient. So yeah, it's not easily done. So here we go. Bring it over here and write it. So I'm on part C right now. And I'm going to write, might be making too much of this. Let's say minus 2x minus 2h plus 7 minus sign in the middle and minus 2x plus 7. Okay, all over h. Well, what we want to do is we want to rationalize. Now, do you remember what that means? They want us to, here, let me write it up here. We keep it out of the way. They want us to rationalize. That means get rid of the roots. So how do you always do that? You at least get rid of the roots in the numerator. How you do that is you multiply the top and the bottom by, and I should get a little more room here, by the conjugate. What's the conjugate? Opposite sign in the middle. So I'm going to multiply by basically the same thing we have there. Oops, wasn't so good. meaning minus 2x minus 2h plus 7 minus 2x plus 7, but plus. See how it's opposite sign and then same thing on the bottom, just identical. No changes. And I did it again. Just gotta make that more careful. Carefully. Okay. Plus sign in the middle. Okay. Whew. That's the plan. So I'm going to put parentheses around these guys. And I'm going to multiply. And it's going to be fun. Here we go. Okay. So that's what it means when they're saying on this part C, rationalize the numerator. They mean whenever you got roots, you want to multiply by the exact same thing, but the opposite sign in the middle. That's called the conjugate. We use that a lot in math. Conjugates. Okay. Here we go. Um, this guy multiplies this guy. What happens? They're identical. What happens when you multiply two identical roots? The roots vanish, right? Think about root 3 times root 3, for example, times. That's a root 9, which is what? Plane 3. See how two root 3's make one plane 3? Well, that's what always happens with roots. When you multiply two of the same roots, the root vanishes. So root of this whole thing times the root of the identical thing, the roots will just vanish. So we'll end up with the root of minus 2x minus 2h plus 7. Now, this guy goes here also. Hmm, that's going to be terrible. I got to squeeze this down. I got to make this smaller. I'm realizing this is going to be big. So let me try again. Okay, that's all the room I got. Minus 2x minus 2h plus 7. There we go. Okay, now when this goes to this, what happens? Well, not much. They just multiply and they just sit next to each other. So it's going to be plus because it's a positive, right? There's no sign in the front, so it must be positive times positive, right? Positive. And then it's going to just be, let me do some color coding. Maybe that'll help. Yeah, it's not helpful. Minus 2x minus 2h plus 7 times minus 2x plus 7. They just sit next to each other multiplied. So he's done. He went to both. Now it's the other guy's turn. This guy is going to go to both. So one at a time. First he goes there. What's going to happen? That's going to be minus the square root of minus 2x plus 7 multiplied by the square root of minus 2x minus 2h plus 7. And finally, this guy goes to that guy. What happens? It's negative times positive. So it's going to be minus and then minus 2x plus 7, not in a root because the roots vanish. Just like root 3 times root 3, which is root 9, is plane 3. Two of the same roots is a plane 1. This root minus 2x plus 7 times the same thing, root minus 2x plus 7, is a plane minus 2x plus 7, but it's negative. Whoops, I don't need to be scribbly. It's negative times positive. It's negative plane minus 2x plus 7. I just wrote it up there because I ran out of room. All over what's on the bottom. Now, on the bottom, don't multiply anything. I mean, just leave it be. Just because I know it's gonna end up nicer that way. Let me show you. It's the root of minus 2x minus 2h plus 7 plus the root of minus 2x plus 7. Okay, there we go. Is that good? That's a huge multiplication. So this first guy went to both, and the second guy went to both. Watch the signs. This guy went boom, positive and positive, positive and positive, and then this negative guy, this is his minus sign, went there. That's why this one's negative, and then went there. That's why this one's negative, right? Watch all the signs. Do you see what really nice thing happens? Um, this cancels this because they're the same thing. The order doesn't matter. It's the two roots multiplied, one of them positive, the two roots multiplied, one of them negative. So they're totally gone. Isn't that nice? That's why we use the opposite sign in the middle, you see, because then you get a positive of the two roots multiplied and a negative of the two roots multiplied, and they cancel. And so it's getting nicer. Can't get worse, I guess, huh? Um, what do we got? We just have that first term, minus 2x minus 2h plus 7. And then we've got the other. Now this minus is going to distribute plus 2x minus 7. Right? Did you see that right there? The minus in the front of the parentheses distributed. Watch out all those little things. H, the bottom, times nothing much has changed. And I'm just leaving it. Now you might wonder, Mr. Couldn't why didn't you distribute that H on the bottom? You totally could. There's nothing wrong with distributing. I just happen to know something nice will happen if we leave it. So there's no rule here. You could distribute or not distribute. It's like saying, I've got 2 times 3. Can I make it 6? Yeah. Or you can leave it 2 times 3. You know what I mean? I'm just leaving these guys as they are because I know something nice is coming down the road. I'm just going to leave it. Okay. So, oh, wait a minute. What am I doing? This root isn't here. This root dropped off, right? Sorry if you've been wondering this whole time. That was so dumb of me. Yeah, that whole root's gone, right? I said it and then didn't do it, right? That was dumb, dumb, dumb. Sorry. The root multiplied the root, and so the root vanishes. No more root, right? Sorry if I confused you. Okay, now you're starting to see the nice thing that's going to happen. Probably popping before your eyes now, right? Look at that top. Something really nice. Minus 2x plus 2x plus 7 minus 7, right? So now we have, what do we have on the top? Only minus 2h is all that's left on the top. On the bottom, nothing's changed. It's still h parenthesis root of minus 2x minus 2h plus 7 plus root of minus 2x plus 7. Okay, now we can cancel these h's. That's why I wanted to leave that h. Because remember, you can't cancel added, subtracted items, but this is multiplied and this is multiplied. That's why I wanted to leave that h out there because I knew that h would cancel. And so what do we have left is our answer right here. Now notice they put the minus in the front. That's fine. It doesn't matter. You can put it in the front or put it in the top. If you put it in the bottom, you're going to have to distribute it. It doesn't matter. A minus sign in a fraction can be in the top, can be in the front, can be in the bottom. Doesn't matter. But if it goes where there's two things, like if it went in the bottom right now, there'd be two things. It has to distribute to those two things. We don't want to do that. So you can leave it in the top. You can put it in the front. The computer knows it's the same. All those are good. And so here, I'll just write a final answer if it's helpful for you. So the final answer then, minus 2 over minus 2x minus 2h plus 7 plus root of minus 2x plus 7. There it is. All right, that's the hard part. We have made it through the hard part. We got rid of the roots from the top. Now you might say, yeah, but so what? They're on the bottom now. Do we want that? Well, Yeah, it's actually going to do something nice. Last part now. Last part is they want us to take the limit of it as h goes to zero. Limit as h goes, that which is the derivative. That's what the derivative is. That's where the second point comes back on the first. The h is the gap, the small jump between the 2 points. So if you let that jump h between the 2 points go to zero, go to no jump, then the 2 points are 1 point. They're infinitesimally close, and you really have this derivative or slope at 1 point. That's what this is all about. Anyway, let's get her done. So limit as h goes to zero of that. So here I'll write it one more time, and then we will put a wrap on this thing. These kind of problems are where they say calculus is not easy. It's not for the lightly committed. You gotta be serious because it's a big pain. So put in zero for h. That part's gone, right? H is zero, gonzo. So then, so what? Well, so once, here, I'll do it in 2 steps. Once that goes in there, okay, we get the minus 2 up here. And then what do we have here? Well, look at it. They're going to be the same thing twice. Do you see that? And that means there's going to be two of them, and the twos will cancel. I'm telling the whole story before it happens. Do you know what I'm talking about? It's going to be minus 2. They're the same now because that h is gone, right? Because this part dropped off. They're the same. So what do you do when you have two of the same thing? That's one of them and one of them. That's two of them. Remember, they're big, fancy like terms. So that's still the minus 2 on the top. The bottom now is 2. I'll do it in the same color if it's helpful to you. 2 square roots of minus 2x plus 7. And then we can cancel these. Why? Because they're both, that's multiplied, and neither one of them are added and subtracted to anything. Now, when I say cancel, I really mean divide by 2. We casually say cancel, but we really mean we're dividing them both by 2. And so what that means is that there's really left on the top a minus 1, right? Because you're dividing them both by 2 is what you, when you say cancel, you mean divide them both by the same thing. So what are we left with on the bottom? Minus 2x plus 7. Can you believe it? We are done. Hopefully that's the right answer. Otherwise, I take it all back. Was the right minus? Yeah, they put the minus in the front. That's fine. Root of negative 2x plus 7. Root of negative 2x plus 7. And it was a 1 on the top, right? Yeah. There it is. Yep, we got it. And so, yeah, like I said before, you could take that negative and put it in the front or leave it in the top. It'll take it either way. So there we go. That's the square root. We just did the, I'm sorry, that's the derivative of a square root function. Now we're going to learn a shortcut in a few days, a few sections, not long from now, but there's the long way, which is kind of terrible.